A model can sound brilliant and still do nothing. The moment an agent actually looks up a record, writes a file, opens a ticket, or runs a cloud workflow, it stops being just conversation. It enters tool calling, and that is where serious engineering begins. Imagine an incident agent helping during a failed deployment. It needs to check the monitoring API, search logs, read a deployment record, and maybe open a ticket for the on-call team. None of that happens by clever wording alone. It happens through controlled tool access. If you let the model invent raw shell commands, raw SQL, or unrestricted API calls, you are not building intelligence. You are building an unreviewed automation path with a language model at the front. That is how teams create outages, data leaks, and false confidence. So in this lesson, I will show how agents move from talking to doing safely. We will break down tool schemas, validation, execution, retries, rate limits, permission checks, and audit logs, plus the one rule I never compromise on. The model never gets unrestricted command power. First, we will define what a tool really is. In agent systems, a tool can be an API call, a local function, a database query, a file operation, a cloud command wrapper, or a ticketing action. The common idea is simple. The model requests capability, but the platform controls the execution. Second, we will walk the runtime path. The model sees the available tools, chooses one, produces structured arguments, waits for the platform to validate them, receives the result, and then decides whether another step is needed. That separation is the foundation of safe agent behavior. Third, we will cover the guardrails that turn a demo into a production service. Strict schemas, input validation, output validation, timeouts, retries, rate limits, permission checks, and audit logs. These controls do not make the agent less useful. They make its actions trustworthy. And by the end, you should have one clear mental rule. The model may suggest an action, but it should never directly execute unrestricted commands against your systems. The execution boundary belongs to code, policy, and infrastructure, not to free-form model output. Tool calling is not the model spraying arbitrary text and hoping a downstream script guesses what to do. A real tool call is a typed request. The model picks a named tool and fills a strict argument object, usually JSON, that the platform can inspect before anything happens. The tool itself can point almost anywhere. It might call a SaaS API, run a carefully wrapped function, query a database through a safe adapter, read or write approved files, trigger a cloud workflow, or create a Jira ticket. The contract stays the same even when the backend changes. Strict schemas are what make this reliable. Instead of asking for, quote, whatever logs seem useful, the tool can require fields like service, name, environment, start time, end time, and max TUOX results. That structure reduces ambiguity, makes validation possible, and stops a lot of accidental misuse before execution. Keep the architecture split into 3 roles. The model reasons over language. The orchestrator decides what tools are available and whether a request is allowed. The executor runs the approved tool with real credentials and returns normalized results. When teams blur those roles, safety gets blurry too. A production agent starts with a tool registry, not with a hidden bag of scripts. Each tool should have a name, clear description, strict schema, owner, allowed caller context, timeout, retry policy, and permission model. That registry is the contract between reasoning and execution. At runtime, the model does not get open-ended system access. It gets a menu. It can see descriptions like get deployment status, query, incident logs, or create JIRA ticket, and it chooses from those bounded capabilities based on the current task and prior results. Before the tool runs, the platform validates the arguments. Types must match. Required fields must exist. Enum values must be legal. IDs must belong to the caller's scope. Strings may need sanitizing, and dangerous fields should be rejected with explicit reasons instead of being coerced silently. After execution, the platform should validate the tool result too. The output must match an expected structure, carry error states clearly, and avoid dumping unpredictable, raw payloads back into the model. Good systems normalize results so the model sees reliable facts, not vendor-specific chaos. Let's walk one request. A user says, find the failed deployment, check the logs, and open a ticket if the rollback also failed. The agent should begin with safe, read-only tools first. That means looking up the deployment state before it even thinks about writing anything. The first tool might be Get Deployment Status. The model fills arguments like service name, environment, and time window. The platform validates them, calls the deployment API with a timeout, and returns a shaped response such as failed, rollback started, or rollback failed. That structured result drives the next step. If more context is needed, the next tool might query logs or metrics, but again, not as raw, unbounded text. A safe log tool can limit time range, maximum rows, and searchable services. A safe database tool should use parameterized queries or approved query templates, never free-form SQL written directly by the model. Only after the evidence is clear should a write tool run, such as create bot incident.ticket. That call should check permissions, attach the reason for the action, log who asked, log what evidence was used, and return a ticket ID the model can reference in its final answer. Doing comes last, not first. The fastest way to make tool calling unsafe is to let the model emit unrestricted shell commands or arbitrary cloud CLI strings. Language models are good at patterns, not at holding your blast radius in their heads. Wrap the operation you want. Never hand over the whole terminal. Another failure is trusting tool outputs blindly. APIs fail. Databases return empty sets. Network calls half complete. If the platform treats any return text as success, the model can confidently continue on top of bad or partial data. Output validation is as important as input validation. Real systems also fail through slowness. Without timeouts, one vendor API can hang the whole run. Without retries, transient failures look terminal. Without rate limits, a looping agent can hammer your own services or someone else's. Reliability controls are not polish. They are runtime survival. And then there is governance. If every tool runs with broad admin credentials, if destructive actions need no approval, and if no audit log captures who asked for what, you cannot explain or defend the system later. That is not agent engineering. That is unmanaged automation. The safer pattern is narrow, purpose-built tools. Instead of run any cloud or command, expose tools like list recent deployments, fetch service logs, scale read-only preview, or create ticket draft. Small tools are easier to reason about, easier to test, easier to authorize, and much harder to abuse. Put policy next to execution. The system should know which user, role, tenant, or workflow is allowed to call a tool, under what conditions, and why a request is denied. Good agent platforms return clear allow or deny reasons so the model can explain limits instead of inventing stories. Treat every tool adapter like a production integration. Give it sane timeouts, bounded retries with back-off, rate limiting, idempotency where writes are possible, and circuit breaking when a dependency is unhealthy. That way, one shaky dependency does not turn the whole agent into noise. Finally, capture an audit trail. Log the request, chosen tool, validated arguments, approval result, execution outcome, latency, and any side effect. For sensitive write actions, add human approval or a review queue. Good agent systems make actions inspectable before and after they happen. So here is the mental model to keep. Tool calling is the handoff from language to systems. The model reasons about the next step, but code decides what is allowed, how inputs are validated, how the tool runs, and how results come back. That boundary is the heart of trustworthy agents. If you are building an agent, check these every time: strict tool schemas, input validation, output validation, timeouts, retries, rate limits, permission checks, least privilege credentials, and audit logs. If even one of those is missing on a high-impact tool, slow down before you ship. And keep the non-negotiable rule in plain language. Never let the model directly execute unrestricted commands. Not unrestricted shell, not raw SQL, not open-ended cloud admin actions. Wrap the capability, validate the request, and keep human or policy control at the boundary. If this was useful, subscribe for more practical cloud and AI engineering explainers from Trustscrin Cloud and AI engineering. In future lessons, we can break down agent memory, approval workflows, and how governed AI connects to real infrastructure delivery without turning automation into a liability.